Good afternoon again, and welcome back to Smart Cities. We have already the third lecture, and I wanted to ask at the beginning, someone of you participated in the Cyberthlon in Zurich over the weekend on Saturday? No? Did you hear about it? Yeah? I mentioned that because this Cyberthlon and what happened there, it was the world's first event of this kind. And it's a very, very good indicator what a smart city and, more important, the inhabitants of a smart city could be. Because it was really a fantastic combination of people, humans, robots, robotic devices, all with the goal to help each other, rather than observing and trying to prevent crime and other things that we often have when we use smart city technology. So it was a very positive pointer into the future of a smart city. Today we come to a quite important topic in smart city and in information cities in general, and we call it the stocks and flows principle. Stocks and flows. Some of you might have heard that or know that. Any students from economics here? No? You are? Yeah, so you should know stocks and flows, right? It's an age-old principle, was invented long before you were born. And how do you use it today? Do you want to say a few words, how you use it today, or do you not use it anymore in economy?
We have a class on system dynamics, and then you do a modeling with it.
Right. And the background, what do you model? Yeah.
So you have different variables, and then you have the drain and the source, and in between you have stocks and flows.
Good. That's exactly the topic, and as you hear, it's not coming from architecture. It's not new, but it's a very powerful principle, and you will hopefully learn in this class how it applies to architecture and design. We are also practicing today, step by step, the so-called flipped classroom that I mentioned last time already, but maybe by this time you know more about it. Can I just ask you who has seen that part on the MOOC already, on the stocks and flows? Should be quite a number. Yeah, you must have seen it, yes. So in the flipped classroom, it would work that you have seen that, not exactly what I'm going to talk about, but the principle explained in this short video. You might have read the texts that we give you in the MOOC with it, and then in class you would actually comment on that, or you would ask me about it. We would discuss it rather than me just standing here and trying to explain it again. So for the next lecture, for the next lectures, please try to do this in the MOOC. Look at these videos before, and then you might, or you will certainly much better understand what we talk about here. So you mentioned the stocks and flows of money. That is, of course, very important. But even this image shows a certain stock and flow. You can imagine anything behind that. But certainly the stocks and flows of space, of light, of ornaments, all of these things you can relate to with this principle. But let's start in an orderly fashion. The story so far, from the beginning, from the bottom, we had 2 weeks ago the cities as complex systems. And of course, ideally they are resilient, they're sustainable, smart, and finally, in the future, responsive. And they develop from production machines to human habitat. And smart cities, as we deal with them this semester, can be a step in this direction. Also, at the bottom, I put the link in case you have missed one of these lectures, then you can look them up there. And the recordings are always under our website. Then last week, it was Mark van der Net, and he talked about the now cities and the future cities. And you saw many, many insights and proposals and ideas about the future cities that he has, observations of the now cities, as he calls them. And he also showed how technology, especially new disruptive technology, is already changing whole neighborhoods in the world and might even change in the future whole cities in their infrastructure and in their behavior. And along this path, now we go one step further today and look at the stocks and flows. Stocks and flows are also related to data, because out of stocks and flows, or to explain stocks and flows, you need data. And in our case, in the city, it will be big data, and you will see how many data you can and will gather from things that happen in the city. Going back to the motivation for this whole course and our work in the last years is this one. We know that in the coming years and coming decades, few decades, more people than ever will move into cities. They will either be born in cities, like in countries and places with high population growth, or they will move from other parts of a country, from the same country, into a city, like in China or in Ethiopia, or they will come from another country and move into a city that doesn't exist, or it's maybe a very small space at the beginning. If we continue to build cities as we do this now, it will lead into a real disaster, because it's impossible that we can afford the same cost and the same footprint in terms of ecology and economy for each new city that we build, compared to most of the cities that you come from. So we really have to look at a massive change of perception and behavior in the construction of these cities. The principle behind that, how we want to improve that, is that of the urban metabolism. And I'm sure you have heard about metabolism in other contexts, let's say in nature or with yourself might be. And here we want to move this urban metabolism view to the city and understand the city as this complex and dynamic system, and it behaves like a complex and dynamic system. If you just look at your neighborhood, where you live now and where you lived 1 year ago, you know either you have changed your position or other people have come into it, and it changes all the time. So it's really dynamic, changing always. We can read and model the system in terms of stocks and flows. So that's the connection to before. And we have to recognize the urban stocks and flows as basic elements of the urban metabolism and as logically available resources. 20, 30 years ago, people were thinking about this metabolism, this urban metabolism, and you had these views that food, energy, all kinds of goods come into the city, into the human habitat, and then you have a big part that goes out again. You remember the dumps that were made, just everything was dumped in the garbage and people just shipped it out and deposited somewhere, open landfills. Who has not seen a landfill in a city? Or on a city or next to a city? No? Never seen a landfill? No? Maybe somebody can explain what that is. You know what it is? Oh, you have to see it, or you have to smell it, then you know even better what it is. So that was really the practice that was handled in many European and American cities. And people saw that cannot continue, so they started thinking of recycling. And this recycling has reached a high level of sophistication today. So many cities do a lot of recycling, and recycling in itself becomes a new business. And what is this principle of stocks and flows? So that should make you aware of it. There it is running already. So it's that little simple thing. So maybe can you explain it, because you're the expert in that one.
Yeah, I mean, the rectangular thing is the stock. So this is like the amount of money that is available at the given second. And you have the inflow, that's the investment, and you have the drain or the outflow. So the relationship of the inflow and the outflow determine the level of the stock.
So it's really a very, very simple principle, as you can see, but you can see already it's dynamic, so it can go up and down. Investment flowing into the stock of capital, flowing out into depreciation or depletion of the stock, and this keeps going on and on and on. It's always dynamic, always something happening. And if you now imagine this principle, just see it as a principle, not as a one-to-one in a city. But this principle, you can apply that to many things. So here, for example, you could have replaced that stock and flow of money with another entity. What could be a typical entity for that in a city? Population. Sure, people. So people are indeed the most important stock and flow of a city. I hate to use that word for people because it's really a terrible description of people. It's not a description of people. But if you abstract their stock and flow, how they behave in a city, it comes very close to that. So people come in, moving from the outside into the city, and they go out of the city or they die. So that is related to the previous slide I showed about these 2.6 or 2.5 billion people that will move into cities in the next 20, 25 years. Okay, now we go back to that one. Right, so people, that's the most important stock and flow. And health is another one. As you know yourself, you have a certain stock, if you want, of health, but you can ruin your health really easily, and then you need a lot of time to build it up again. So you can also see your health as a certain stock and flow. So people, the most important one, health, another one. Then there are more, water, for example, and capital. Capital is the one that we saw at the beginning and where the whole principle comes from, but water is a very good stock and flow as well. Just think, at home, you open the tap, it's a flow, it's very obvious, but then you put some into a glass, it's a stock, you drink it, it's a flow again, and you can just see how it keeps working on and on and on. You can also use water for all kinds of things. This, for example, somebody knows this place? One person should know this place. Zielsee, right. So it's a lake in central Switzerland. And this lake is actually also a stock of water. The water comes normally from the glaciers, or the melting, or from the snow. And it's stored there for a while, and then they release the lake to make electricity. So then it becomes a flow again. It flows into Lake Zurich, becomes something like a stock again, then flows out the Limmat and becomes a flow again. So this water is a stock while it is there. It can also freeze, as you see here, the water is frozen, but underneath it's still fluid. So it can even change, the stock can become even more explicit rather than being fluid, it becomes a real stock, a frozen stock of water. And that, of course, is related also to capital, because every drop of water going out of there makes money because it creates electricity, generates electricity, which then can become a stock and flow of money, as you saw before. Another couple of very important stocks and flows are energy and materials. This place you probably know as well. You have been there, I'm sure, some of you. No? Pompeii? Yes, it is Pompeii. So there you have a wonderful, terrible example actually of stock and flow. The city was there, the city was built. You see, each one of the materials was not there before. It was imported into the city and it was deposited there for a while to become a stock. So all these bricks and all these natural stones become a stock for a while. And then, as you know from history, these awful events happened a couple of thousands of years ago, and the flow of ashes and of lava just covered the entire city and killed thousands of people. So there was literally a flow of material coming from the volcano, covering everything. And then it became really a stock for hundreds of years. Then people started to rediscover this city, and they started to unearth it again. And then the stock of the lava and all of this was removed, became a flow again, used in gardens and so on. And now we have here the old remaining stock of the city. So this energy and material are also very important stocks and flows. Another example for that, energy and material. This building is now completed, of course. It's the TEA Media building here, but you see it was really done with wood and concrete. Our Japanese guest, you know the architect? Probably. Do you know the architect of the? Yeah. Everybody knows that. And you could see it's a material that has grown somewhere else, cut down the trees, laminated, brought here to this place, become a stock for a while. But you could easily use this material later, just cut it into pieces and turn it into a flow again and produce energy with it. As a matter of fact, in the village where I live at the moment, in Einsiedeln, recently, just last week, a new little firm was founded that has the purpose just to take the stock of old building materials, old wood that you cannot do anything with, take this stock, shredder it, and make energy out of it. So you turn a stock into a flow, and you connect energy and material through that. In ancient times, it was also known that it is very much related, energy and materials, and it was even more known that you have to bring those two flows and stocks together in a careful manner. So here, these monks preparing to build a monastery, transporting the goods, the bricks, the water, and so on, and then actually building the building. That was a very sequential description of the stocks and flows from simple material, energy, materials, to a finished building. These are a bit more difficult, stocks and flows of density and space. All these other stocks and flows, they are known in literature, and people have talked about this for a long time. The one of material, for example, is a whole science has developed around it. The material flow analysis, every city today has a more or less good understanding of their own material flow analysis. But the stocks and flows of space and density are a bit more difficult. This is a picture from Singapore, and you can see stocks and flows and density that we have here in Europe or in other places which are on low-rise buildings in cities are totally taken or turned upside down here, because these buildings here, they are, of course, high density, they're very tall, but in between there seems to be nothing. And then suddenly on the top there is another part of the density and of the space But even a more mundane example might help you to understand. Take, for example, this space here, where you're in now. And this is incredible, because this space is the same size every day, but it changes its function and its spatial quality every day. In this space, probably, so far, I don't know, at least 10, 20,000 people have been in that space over the last years, just coming in and out. It used to be a working space, which is now over there with big tables in it. This wall was not here, so it was one continuous space. Then we added this wall, moved the tables over there, moved this furniture here, and immediately it changes its spatial character. Sometimes here this space is extended tremendously all the way to any other part of the world. When we have a video conference with this one here, people appearing here, you're sitting there, and suddenly you have expanded space by thousands of kilometers in your perception. It's still always the same space. At the same time, density is changing. Now we have quite a high density here with all of you in here. On the other side is the other chair of Dear Cable. And when you go away, it will be quiet for a while. Then the next course will come. It will have a lower density, but the space is always the same. So remember, this is a different perception of space and of density than we normally have. You can also have it in a continuous way, because this part of the space here belongs to that one, but there is a very fine line in between those, this being the fine line. This projection wall projecting to you is used on the other side as a pin wall for the work of Dear Cable and his group. And even the use of the space is controlled very carefully, not controlled, but managed very carefully, because Dear Cable and his group, they know when we have a class here, a lecture, they do not make their meetings, and vice versa. And this is done in a very nice way, because they can hear somebody is here sitting there listening, so they go into their offices and work. Once we are done here, they come out and have their meetings. And that happens every day. So it's also like a stock and flow of density of people right here in this space. And if you look at your own house, at your apartment where you live, just try to think it through. You find this phenomenon everywhere. Another stock and flow, transportation and information, or mobility and data. This stock and flow is very special because it is, you cannot grasp it. How do you visualize information? Stefania, do we still have these objects back there? I think maybe you can get one. So how do you visualize information? How does information flow, materialize, and flow again? When is it a stock and when is it a flow? And we have here two examples. This is from our Value Lab downstairs. And in the background here, we have a simulation of the whole Dübendorf area, in which we took information from buildings from different cities and used them to generate a layout for the Dübendorf area. So this information materialized for a while and then went away again. Here we took the other way. If you look at this one here, do you have any idea what that could be? This one on the right? It's very abstract. Does anyone live in in Richterswil? No. In Wädenswil? No. Anyway, that is a place on the Lake Zurich where every evening at a certain time, air comes down from the Sihl Valley and flows down in the same direction. So this is a materialization of the wind speed and intensity and direction of the wind that comes down from one part of Switzerland into another part of Switzerland. So it's a materialization of information. The same thing, this one here. Do you have an idea what that is? Strange, huh? Anyone from Spain? Yeah. It's from your country. No, that was before cloud computing. So, but it's Spanish, but it's your temperature and solar intensity I think it's in Alicante. And just materializing this information, this data, sun shining, you record the data, and then you can, of course, make tables and just, some people can read tables. Other people cannot understand what it means. You can build it, it looks like this. And that one, what was that? That was also something has to do with wind and solar intensity. And you could play even with the individual elements that are represented here and make holes in them, for example, representing intensity of a certain kind. Yeah?
I mean, this looks quite nice, but what does it tell us about the data? This kind of representation of the data?
For some people, it means they can understand data for the first time over a period of time. These are all data over time. So this is a flow of data over time frozen in materialization.
Isn't it that it's even harder for people to understand data in a multi-dimensional space?
It is. It is. But that's why this is made by your colleagues, and each one tried to find out the different way how to explain data or flows of data better. And so they came up with this, We have a whole collection of those. Some, I think, were very you would understand them immediately, and others were more complex, like this, especially if you have nothing written on them, so you really don't know. Huh? It could be anything. But reality is there's real data, measured data behind that. It is to show you that even information and data you can materialize if you want, but then it takes on another form. You can make a stock of this and then use it, and then it becomes a flow again. This view of a city and of the functioning of a city was actually the idea behind our first big project with the ETH in Asia, the ETH Future Cities Laboratory in Singapore, where several professors from architecture, from civil engineering, from computer science, from electrical engineering and others got together and formed this center. And in that center, we decided to really study the city carefully with regard to the stocks and flows that I mentioned. So different scales and different stocks and different flows. The scales are familiar to you in architecture: small, medium, large. The small scale would be the scale of a room, of a building. The medium scale would be of a quarter, of a neighborhood, like here, the Science City, or a small town. And the large scale would be a whole territorial planning. And then the stocks and flows, you know them by now. It would be space, energy, materials, people, capital, water, information, health. You could just keep on going. But these are the ones that we try to study. And then we put them into projects. And these projects then explored for example, the stocks and flows of energy on the small scale of a building, and you can see it reaches from the room all the way maybe to half a quarter of a city here. Or digital fabrication, or architecture and construction, all for stocks and flows. Yes?
Coming to the stocks and flows, but wouldn't a very central one also be life quality?
Quality.
Like life quality and so on.
Definitely.
It's one of the main ones in the city.
It is the main one, but it's hard to study it by itself. You can see the result of it. You can measure people think you can measure the quality. They cannot agree on the criteria, but I think it is possible to measure quality. But how to achieve quality? Either you look at what quality is and then analyze what stocks and flows the city has and then try to invert it and make a better city or a good city this way. Or you have to invent new criteria. As in architecture, it's often done. But quality is definitely another stock and flow. It's actually a nice one because it changes over time. And it changes in intensity. Cities become very attractive or less attractive.
And it's linked to all of them.
It's linked to all of them. But that's the point. Every one of them is linked to all of them. And that's why towards the end of the semester we come to this view of a city as a complex system, the complexity science, where you can express somehow this total connection between elements without having simplistic causal relations between them. Yeah, quality and health is another one. That's also related to all of them, but it's hard to say. Design a healthy city. It will be different in every place, in every time. But what we could find out was that some scales or some stocks and flows are applicable to certain scales, like those one to the smaller scale, those ones here to the medium scale, and then some of them to the large scale. And our work, our contribution to this whole exercise was and is that we built a simulation platform that is covering all the data that is coming from these different research projects, taking in all the data, then visualizing the data and making them available to each one of the other projects. Let's go quickly through a few applications of these stocks and flows that you get an idea. And they are all very important for the smart city or the responsive city. We know that now. At this point when we did that, smart city, responsive city wasn't even existing. But now that we have done this research work, we know what we need to make smart cities and responsive cities. So those that have worked with Arno Schlüter and his class or in the building physics, they probably know this. Artificial image, because it's not a real picture taken, it's just a picture stitched together, but each one of them are real, and these are buildings, and they're sitting next to each other, and you can immediately see this must be a hot climate. So these are all air conditioning units on the outside, and that is from the low exergy project in Singapore. That means the low exergy project is a stock and flow of energy, and that's why it is on the building scale, mainly on the building scale and the city quarter scale. So here you would have the stock and flow of energy coming in as electricity and basically turning to hot air coming out here, leading to all the problems that then these places have because they're not livable anymore. And coming back to your quality question, this, if you have to live right next to those or you have to be in a back alley next to those, the quality goes below zero. And they took this principle and turned it around because they saw this is reality now, and they thought of the future. Think of Mark's lecture last time, the now city and the future city. So they took this step physically. They saw the now city. This is how it is now. It's unbearable. It's hot. It stinks. It's loud. What can you do with that? And they turned it around and said, we have to change the way we air condition buildings. And they actually designed and built then this alternative way of air conditioning for this actual building in these 2 floors here in the United World College of Southeast Asia in Singapore. So that is stocks and flows of energy. These 2 young gentlemen you know very well. If you have been to the new building, have you? The new robotics building here on campus? You have seen it, right? You were at the opening. So that was 5-6 years ago. That's how they started this application, how to use robots in a space to construct buildings. This was their start at this time. You see, the robots are much smaller, but the ideas were already there. So this is the stock and flow of material, of course, how you can handle it and combine it with information embedded in the robotic infrastructure. Then the stock and flow of material also. Another wonderful example. Estefania, could you steal a material sample from there? Anyone? From the look there on the table. Maybe there's one. No, on the back, the physical material. That's too heavy. No, this piece. Yeah, this. Oh, it's screwed to it. Okay, you have to go there later. But the point, you know it, right? This is bamboo material. It's not bamboo, pure bamboo. It's laminated bamboo. Bamboo is split. It's cooked. That the sugar goes out. Then it's combined under high pressure with a conglomerate, with a plastic, basically. And that makes a material that looks like this, which is very hard, very dense, and it has an incredible tensile strength. You can see it here, which is higher than steel. Well, this would be the tensile strength of steel, this. Huh? And this composite material with bamboo is higher than steel. It's quite amazing. And this is, again, the stock and flow of materials, because here, the green, you see all the places where bamboo is growing naturally, and you see also all the places where normally there is not much steel being produced. Like all of Africa here, the steel has to be all imported, but bamboo is there. So the stock and flow of material, of building material, could be changed completely by just using a different material, replacing steel with this bamboo composite, for example. So that's a very striking example of stocks and flows, different stocks and flows. Housing density, Sasha-Mens, also one of the stocks and flows in Singapore that we're dealing with. And then this one is quite stunning also, the transforming and mining of urban stocks. Urban stocks, all of these are urban stocks. They're all materials. This building also has stocks. It has concrete. It has less hard materials here. It has glass. It has steel. It has natural stone. And you can mine this stock. In the old days, one would have just thrown it away, trashed it. But now, every one of these materials is valuable. And again, our colleague Dirk Hebel, he's working on a big book on identifying each material in a building, the value of it, and making it part of the urban stock. Because if you know that stock, it's like money. You can sell it, you can buy it, and you can reuse it. Uta Hasler, who retired just a couple of years ago, she was really working on this very carefully, and she made some incredible, with her groups, and incredible visualizations. This is a part of Singapore, of the city of Singapore. It's always the same part. And you can see 1846, 1893, 1930s, 1970s, and 2008. How you think something like a city which has been built, a stock of buildings of bricks and steel and everything, should be stable, right? But it's not. Even there, you can see how it increases, the density increases. There you can see always the new stock and the stock that was torn down. And in the 1930s, it was densely built up. You can see all this red one is all built up area. But then suddenly in the 1970s, many of those buildings here just disappeared. They were torn down, and they were used for landfill or land reclamation, as it's called there. And so the stock became a flow. The whole buildings just vanished and moved away into the water or into another place. And it keeps going on, a constant transformation of the city. And that can also be observed. Kees Christiaanse is doing research on that, the stocks and flows of density. If you compare these big cities, Singapore, Shanghai, Shenzhen, Bangkok, you can see actually how the stock that seems to be here, Shenzhen, this is the old part of Shenzhen, where just everything was extruded, the buildings were just extruded by 10, 20, 30 stories compared, and then whole parts were raised for new buildings, how that compares to places like Shanghai or Singapore. So you get a very distinct profile of each city. If you remember last week, Mark, when he showed the communication patterns of cities, which is also like a frozen flow of information in time that he could visualize, here you can really identify and compare cities in the same way, because that is a flow of information, of building footprint information over time. The density in itself is also a flow and a stock. And you can see from this work by Christian Schmid, who's also in the Singapore project, how the perception of density that we have, that the United States, East Coast, West Coast, Europe are so densely populated. It looks pretty scarcely populated if you compare it to these parts of Egypt, also developing parts of Africa, and then, of course, of northern India, this part of China, and probably the most densely populated island in the world of Java, where already more than 150 million people are living, with the capital Jakarta having more than 30 million people. And all of this develops in a few years. It's not hundreds of years as it used to be before. It's in a few years. So it's a really flow of people, of density into these areas. Happens in South America the same way. Marc Angelil did the research on that. And the other stock and flow, which is incredibly important, is water. Christophe Giraud. If you read the newspapers, you would have just read recently that finally happens that what he and his research group were asking for a long time. This is the Ciliwung River in Jakarta, a river that comes straight from the volcanoes. And on the way to the city, people, because they have no waste disposal possibilities, they throw the waste into the river. So the waste flows down the river, finally into the sea. But some things get deposited. So the riverbed is coming up more and more, sometimes 2-3 meters. So the flooding that comes every year gets higher and higher, and more people have to leave the city, 200, 300, 400,000 people. And so this dredging of the river is very important, because that would reduce flooding, would make the river more clean, and would improve the quality of living. And combined with that, Christophe Giraud and his group made proposals how people and buildings could react to this condition. And finally, the stock and flow that you're surrounded with every day. Let's see. Who lives on campus already of you? You made it. 1, 2, 3. This is great. So you don't have to do that. You don't have to do mobility during the day, at least. You don't have to travel from home and back. And but normally in cities, in big cities, people have to do a lot of traveling, lots of transportation. And that in itself is a very interesting stock and flow. You look at your car, if you have one, few of you will have one, but it's sitting there normally 23 hours a day or even longer, doing nothing, and the rest it's moving around quickly or slowly and then sitting there again. And in a city, it's the same thing. We have immense number of cars, but the city of Singapore restricted the number of cars to about 850,000. So he said that must not be a larger stock than 850,000 cars, because otherwise there's too many traffic jam, cannot move anymore. So it was a top-down decision to restrict this number with financial means, with the stocks and flows of finances. But then you can still simulate how these cars are moving. And Kai Axhausen and his group did these wonderful simulations. And you can see the time running here in the morning. Now it's 6 o'clock, the traffic is getting really dense, and you can see how it slows down, how you have some green parts where it's still moving, other parts where it's really getting stuck. You see these parts here, this is the industrial part. It's relatively low density, but you have other parts like here, the downtown area, where you have a very, very This is happening in every city today. And here comes the big challenge for the future, because people say, and they simulate and they calculate, that out of these 800,000 cars, maybe you would need only 200,000 or only 100,000 to get everybody the same transportation that they need. Everyone who owns a car said, never, I want to have my car. But other ones maybe say that, yeah, it makes sense. We can share them, we can have autonomous cars, we can do all kinds of things, and that would reduce the number of necessary cars, and it would reduce all kinds of pollution, noise, and the other things. Simulation is an important field with data, artificial population simulation with data on a city to simulate scenarios for the future. And this is a very, very good example for a smart city, because with these simulations, you can show how the city could be in the future. And you could make it as good as possible. Coming back to your quality aspect, if you see less cars as a quality, you can use this to show how it would be possible to arrive at this situation. Okay, so this is MatSim, the name of the program, and that has been used in many places now. Now, stocks and flows coming into reality. This was all practice, this was all theory, but now it's really real. And that just came up this morning. I sent this around to some people here. This is the same city, Singapore, and we are getting involved now in the design or redesign of this part of the city here. So Singapore in itself is already there, but this part here is now part of the harbor. There are hundreds of thousands of containers sitting here. All of those will be moved back here, and this will become part of the city, a new city. So we can apply all these stocks and flows ideas that we had in this one. And literally you can go through them. The people, where will they move? Where will they want to move? The material, what is this built on? Because it's all water now. Where does the water come from that they need? Where does the electricity come from, the energy? How is the stock and flow of the temperature? How is it impacting the heat island effect, and so on? All of these things can be asked now in practice on this very site. It's called Tanjong Pagar. And some of you maybe in the future might be interested to work on this project as well. It will be starting soon. And together with the group from Kees Christianse and also Vittorio Lampugnani, we will try to get this idea of the stocks and flows and use it to make the best possible new city here in Singapore. Okay, let's come to the end. Your exercises, you're doing great. The ones that you send in, they produce new insights into future smart cities definitions. Because when we see what you do, we have to redefine what the smart city could be. You might not realize it yourself when you hand in your exercise, but each one of them is very, very interesting, and it means we have to redefine some of the assumptions we had about smart cities. Smart cities, as you know, it's not totally explained, it's not totally fixed what it is, but it is in the process of being defined, and you do part of the definitions now. So, congratulations. The stocks and flows, they are fundamental concept for smart cities, for any cities, to understand them and to develop them for the future. So that was the theory. Next week, we move more into concrete applications, and we'll start with a second exercise. And that will focus on measurements, because you need to measure something in order to get data, in order to improve something. So with that, I want to close, and thank you for your attention. See you next Monday.